Hello, everybody. Welcome to day 2 of e-learning. I hope everyone is doing well at home and you're not getting too stir crazy. In this video, I'm going to unfold some of the major relationships within inscribed angles in a circle, and also I will reference some key terms in the descriptions here that we haven't had a chance to go over too much based on the circumstances of us not being in school. So bear with me, and if you have questions, feel free to use Remind 101 to reach out to me, or you can use Google Classroom. I hope that platform is working well for you. The first thing we're going to look at here would be the relationship between these three angles, and I think we have done this before. However, I'm going to reiterate it because it is the concept that's going to take us through the next three parts that I'm going to convince you of certain relationships with the angles in a circle. So we have angle X, angle Y, and angle Z. Well, one relationship we know is that Z is going to be a linear pair to the adjacent angle next to it. So this would also equal 180 minus Z. And we also know that if we add up any three angles in a triangle, it's going to add to 180 degrees. So we'll effectively get X plus Y plus 180 minus Z, and that has to equal 180 degrees. Now, doing some algebra, we can subtract 180 from both sides. We can also add Z to both sides. And we'll get X plus Y is equal to Z. So this is the exterior angle theorem. And what it says is that anytime you have a triangle and you know two of its angles, so for example, X and Y, the angle that you don't know and its exterior angle, the exterior angle has to be equal to what's called the two non-adjacent angles, okay, the sum of them. So with that concept in mind, we are going to look at, well, and just for some context, maybe we'll create one scenario here where let's say this is 30 and this is 70. Anyway, you look at it, this angle here has to be 100. It's the sum of the two non-adjacent angles. But not knowing that, you could also say, all right, I know these two angles are 100 degrees, which means this one has to be 80, and then its linear pair would have to be supplementary to it. Okay, so it always works out. In the next one, I'm going to convince you of a relationship here regarding the inscribed angle. Now, inscribed angles, you saw a video on it yesterday. An inscribed angle is any angle whose vertex is on the circle. Now, when I say on the circle, I don't mean the center of the circle. On the circle would be around the circumference. Okay, that's more of a familiar term to us. And it's directly related to what's called its intercepted arc or included arc. So if you were to extend that inscribed angle, the arc that is inside of it is directly related to the measure of that. And the other angle that we'll reference as well is called the central angle. Now, the central angle, its vertex, unlike the inscribed angle, its vertex is coming directly from the center, hence central angle. And it's always, the measure of that angle is always equal to the measure of its intercepted arc. So they are directly equal. So for example, if this is 100 degrees, then this arc is measured in degrees as 100 degrees. Okay, so now there's a relationship now with the inscribed angle. So what do we know here? We're trying to look at the measure of DCE. Okay, so that would be the inscribed angle. And then we have DAE. So this is the central angle. Okay, I'm going to look at the relationship between these two. So in this diagram here, what we can see is that there's a bunch of radii, and we know that all radii to the same circle are congruent. So I know that all three segments here are radii, therefore they are all congruent. And we have two different isosceles triangles. So I also know that base angles of an isosceles triangle are congruent, so this will be x, and this will be y. Now using what we just saw above in the exterior angle relationship, that right here, this angle has to be 2x, which will be the sum of the two non-adjacent angles, right? Because this is the exterior angle to the triangle on the left-hand side. Similarly, to the triangle on the right, the sum of its two non-adjacent angles, y plus y, would be 2y. That would be this angle. So there's a relationship now that if you look at DAE, DAE has a measure of 2x plus 2y, which is also equal to the measure of the arc DFE. So DFE. And the notation for arcs is literally, we just put an arc above it. And that's also equal to the measure of angle DAE. The measure of DCE is x plus y. So how do these two relate? Well, we see that measure of DAE is actually twice as big as x plus y. So if we look at a circle with all of the without the markings on it, here's an inscribed angle. And if I have the central angle as such, and let's say this is 100 degrees. That means that the intercepted or the inscribed angle would have to be half of that based on the relationships we were showing above. So this would have to be 50 degrees. Now, if you don't have both of the angles, you can still do the same thing by looking at just what's called the included arc or the inscribed arc. So the central angle is always equal to the measure of its intercepted arc. So that's 100 degrees. So if I don't have the central angle and inscribed angle, and I just know that the inscribed arc, or included arc, it's all the same thing, that's 100 degrees, then the measure of the inscribed angle would have to be half of that, just as it is half of the central angle. So this would be 50 degrees. And that is the main concept we're going to be driving home here, is that the inscribed angle is always half of the measure of its included arc. So hopefully that was convincing. On to the next problem. All right, this is a specific case where we have a diameter. Now, a diameter has to go through the center of the circle. Yesterday in the video, you got some information on a chord. A chord is any segment such that the endpoints are on the circle. A diameter is a chord. It is the longest chord of the circle, because anywhere else you make a chord, it's going to be smaller than the diameter. And then one question came up, what's the difference between a chord and a secant? Well, a secant is very much a chord, but really it's the extension of the chord. So now the segment becomes a line. Now it is a secant, and it intersects the circle in two different spots. Different than what's called a tangent. A tangent intersects the circle in just one spot. Okay, and there'll be more to come on the relationships of both of those soon. But back to this problem. We want to know how x and y are related to the measure of ikj. So we are going to get back to the same concept we did in the first part with the exterior angle theorem. And we can see once again we have radii that are all congruent, which means we have isosceles triangles. This will be x degrees, this will be y degrees. And exterior angle theorem says that this angle would have to be the sum of the two non-adjacent angles, which would be 2x. And then this angle would be equal to the sum of the two non-adjacent angles, which would be 2y. Now, what would happen if you add up 2y and 2x? These are linear pairs. So linear pairs we know to be supplementary. If I add them together, that would have to equal 180 degrees. Now, doing some algebra, dividing everything by 2, we can see now that we have y plus x equals 90 degrees. So what we're showing here is that when we have a diameter and we have an inscribed angle drawn as such, so that the intercepted arc is right here, which is actually a semicircle, so this is 180 degrees. This inscribed angle is always going to be equal to 90 degrees. So anywhere you have an inscribed angle, and I can draw an infinite number of these, what's always true is that the included arc is always a semicircle. And any one of these inscribed angles I look at will have to be 90 degrees. You can go ahead and sketch this out for yourself, but you'll never be able to do this without making a 90-degree angle, so that's really cool. And lastly, the relationship between inscribed angles in a circle. So it's such that it is what's called a cyclic quadrilateral. Meaning, okay, it's an inscribed quadrilateral, just four sides on the shape, okay, and all points are on the circle. So if we look at angle x, it's related to the measure of its inscribed arc, which would be twice that measure. And if we look at its opposite angle, y, it's related to its opposite arc, which would now be 2y. Well, what happens if I add 2x plus, sorry, that should have been a y, 2y plus 2x together? Well, if you look at the circle, that's going to equal to 180 degrees. So that means that if I divide everything by 2, y plus x would have to equal 90 degrees. No, that's wrong. This should be 360. I'm trying to hurry because my video is going to run out. This should be 360 degrees because we all know a full circle, the measure is 360 degrees. So when we divide by 2 to everything, this will be 180 degrees, which means opposite angles in a cyclic quadrilateral are going to be supplementary. So if I know that I have some shape here, and this is 30 degrees. That means the opposite angle would have to be 150 degrees. I hope this helps. Good luck on your practice. Let me know if you have questions.